So we're live now, Hart, so we're good on our end.
Can you share the screen? Can can we hear him through? David, can you still hear us?
Yeah, I hear you.
Okay, perfect. Can you stop sharing?
Yeah, that'll be me. Okay.
Or who's sharing? Oh, it's okay. Sorry, David. Of course, I started at the end. Sorry, Sophia just got locked down. We were waiting on her.
Quick question. If this is being recorded, can we get the recording also? Because I'm in the United States and it's the holiday.
Yeah, I'm gonna
yeah.
send the recording out to everybody who signed up.
Thank you. Thank you. I appreciate you guys. Thank you.
Of course.
Absolutely. All right. So let's get started. Thank you, everybody, for coming today, and thank you for coming online. It looks like we have a lot more people online than in person. Um, Before we get started, I want to emphasize that all are welcome. Please follow our code of conduct. If you aren't familiar with it, just be friendly to people. And I am obligated to show the antitrust notice as well, so please follow that. With that being said, here's today's agenda. We have 4 presentations. I'm going to keep mine relatively short so you can listen to the more interesting stuff that people are doing with Besu. And with that being said, let's get started. Excuse me, let's get started. So I'm going to talk a little bit about Hyperledger and why open source. So what is Hyperledger? For those of you that aren't as familiar and are learning about the community, Hyperledger is the open source global ecosystem for enterprise blockchain technologies. We're a sub-foundation of the Linux Foundation, and that we host all of the blockchain projects and associated projects that are in the Linux Foundation. So the Linux Foundation has more than 1,000 different projects at this point, and we group them at the Linux Foundation into sub-foundations for operating efficiency. So we inherit all the guiding open source principles and guidelines of the Linux Foundation. So why Hyperledger? Well, we believe that open source, and not just open source, but open development and open governance are the future of decentralized technologies. From our perspective, you're only as decentralized as your weakest link, and it makes no sense to build a decentralized system in a centralized way. It's just another method of control and centralization. So some recent numbers on Hyperledger. These are not completely up to date. For instance, we had a new project come in just 2 weeks ago, but we have a large community. Sorry, David?
I think it was somebody off mute.
Okay. We have a large community that continues to grow. And you can see, lots of people only know about one Hyperledger project or maybe 2 Hyperledger projects. But we've had a lot of Hyperledger projects and we've had even more. This timeline doesn't have 2024 yet on it. But today we're mostly talking about Besu and Ethereum. And lots of people don't know that Hyperledger has been involved with the Ethereum community and with Ethereum for quite some time. So how many people here remember Hyperledger Burrow? Anybody? Sophia? A lot of people. Yeah. So this was a project that was really way ahead of its time, which did EVM support for a number of different chains, including their own. So Ethereum has been around, since early 2017 as a project. The Enterprise Ethereum Alliance joined in 2018. The enterprise, excuse me, the EF itself joined in 2019. We continue to work closely with the EF. Besu joined in 2019. And there's been more stuff going on, including, the EF Client Incentive Program. Besu has been recognized as an important execution client in the client diversity goal by the Ethereum Foundation. And I think it's about 15% of mainnet runs on Besu today. So the goals for today, well, we want you all to learn about Besu and its applications. But importantly, we also want to, help you all explore possible opportunities for collaboration. So how can you get what you want out of the community through collaboration and contribution? So, I'll say very briefly a personal story. The Cacti project was started just by discussions at a Hyperledger event. That was many years ago. So I hope, you all can have similarly fruitful discussions and collaborations. So if you want to get involved, I'd first encourage you to check out our Discord. Is everybody here on Discord? I know some of you are, because I bother you on it. But if you haven't signed up already, definitely sign up for the Discord. It's how the community likes to communicate these days. A lot of the executives and higher ups are sad that developers don't want to use email anymore, but tough. And here's just a whole page of links you can use if you want to get involved. And we'll make the video and the slides public, and David's posted the link. So thank you, David. So please join and please get involved. So that being said, I'm going to transition a little bit and just talk about why open source is important. In some sense, I'm probably preaching to the choir here, but I just want to reiterate, why I think open source is the way to go for development in blockchain and decentralized systems. So there are a lot of reasons, and a lot of them are, simply economic. If you're choosing a platform to build on, it's better if there's an open core and a little bit built on top, because it means there's less potential for vendor lock-in. It's much easier to have a diverse vendor ecosystem with this case. And this, drives down prices for development and makes it, easier if you're buying a solution to switch. Importantly, we avoid duplication of effort with open source. So most projects solving the same problem are likely to be very similar for most of the code, right? If you think about CBDCs or central bank digital currencies, most of the solutions have, very similar requirements, right? We don't need each country to build its own CBDC solution from scratch, right? That would just be foolish. And instead, people could collaborate on a common core and then build out the individual components on top that they need. And this R&D point, sort of emphasizes this as well. Open source is also likely to help drive open standards. We see that constantly. And having, a good permissive license protects users and contributors while still allowing for innovation. And in Hyperledger, we require Apache 2, which we think is the best license for this. So, this hamburger, I guess, often describes how modern applications are built, right? There's an open source framework, there's a little bit of custom code, and then there are more libraries used to solve problems sort of on top of all of this. And, even if you buy a closed source solution from someone, this is what they're probably going to give you, right? A huge amount of closed source code is actually repackaged open source code. But of course, having open source software that works is about having a good community. And some, things that are important and that we ensure in the Hyperledger Foundation are sort of a governance duocracy. And what this means is the people that do things and that make positive contributions get to decide the governance sort of in proportion to their contributions. So if you're doing a lot for the project, you should have more say in the direction of the project than someone that only does a little bit. You know, IP clarity is important. I know developers don't like to deal with this, but you know, it is an important thing to have. And you know, every open source project should have a good commercial ecosystem around it, or it's probably not going to last very long. And finally, having a neutral home is important, right? You know, you don't want your competitor to be in a complete control of an open source project that you rely on. So we see people, you know, talk about, well, what are the reasons, you know, not to work in the open? Why would I not want to work in open source? You know, if you contribute a project or contribute code, you obviously have less control over the project, and competitors, you know, use your code. But, you know, in practice, the economic efficiency substantially outweighs, you know, this in most cases. And lots of people, I would say really ironically, are sort of afraid to show their code to the public. And my comment is, if you're afraid to show the code to the public, it probably shouldn't be in production. I'll just leave it at that. Some misconceptions about open source. So we get a lot of people, particularly in the financial industry, that I would say are still sort of stuck in the Y2K era of development. And we get things like, you know, oh, you know, can't hackers, you know, attack us if they see our code? And the evidence is that there's nothing to suggest that open source projects are less secure, and there's lots of evidence to suggest they're more secure. All of the critical software, you know, used today on the internet, I think like OpenSSH, is open source. People often complain about provenance, and you know, well, if you look at all the largest contributors to many open source libraries, probably people you trust anyway. And finally, I want to emphasize that, you know, open sourcing parts of a code base is not a requirement to open source everything. We understand that, you know, some code makes sense to open source and some doesn't. So I might be preaching to the choir here, but, you know, I do want to continue to dispel the myth that open source is less secure than closed source. Obviously, there's some open source projects that are more secure than others, and it's very important to have a good security process. But you know, as a whole, you know, we certainly believe that open source benefits security. And finally, I want to say that not all open source code is created equal, right? So I've listed sort of here 4 kinds of open source projects. And you've probably seen all of them in the wild at some point. So the first one, you know, that we sort of have is I put it politely here as a public demonstration. You could impolitely call it a code dump. But this is when somebody just pushes code, you know, out in public. You know, maybe they just check the box on the GitHub repo, so people can see it. But you know, is it updated? Is there a roadmap? Is there anything going on? You know, I don't know. You probably wouldn't want to use this code, right? Then we have, you know, an open product. And this is sort of, you know, a company or entity. Open source is a piece of software that's really just a product. It doesn't allow outside contributions, but keeps a roadmap, regular releases, follows best security practices, and so forth. And then as, you know, we sort of move down the spectrum, right? We have benevolent dictator projects. This is when a company or a person open sources a project, but maintains full control over the project. You know, if I'm the benevolent dictator, I might let you make contributions and fix bugs and stuff, but I'm not going to let you, you know, influence the roadmap or anything like that. And then finally, we have open governance, you know, which is code with documentation, decentralized governance, a neutral home. Anyone can join and contribute. And this is how, Hyperledger and more broadly, the Linux Foundation work. And I have a little more about all of these. You can kind of see the increasing benefits as you sort of increasingly open your code, right? Even if you just make your code public, right? It's an advantage because, you can show off, people can see your code, you can audit it. There's security advantages, and potentially others can benefit from seeing your code as well if you want to have an impact. Again, it's hard to get contributors if you sort of just dump your code. People are unlikely to use your code either because they have no assurance about the future. I listed as a downside. If you're doing a bad job, people will know. But if you're building a production system, you shouldn't be embarrassed to show people your code. And if you're just experimenting, then who cares anyway? As we move towards, more openness, people are more likely to use your code since it's well supported. Once you start opening up for contributions, there's less work for you. You're more likely to have adoption because people can help fix and deal with their own pain points. And finally, in a fully openly governed project, it really incentivizes contribution because companies can play a role in governance, and a diverse group of contributors means that users can easily be convinced of the long-term stability and viability of a project. People want to be assured that if one person or one company goes away around an open source project, it's going to still be there and they can still invest in it. So with this in mind, just a little background on open source. Why do organizations use the LF? So the LF, is a neutral organization to host the code, which is what you want. But it turns out it's very hard to put together an open source community from scratch. There's a huge amount of legal work. There's a lot of expertise that needs to go into it. And you can do it yourself, but it's easier to not start from scratch. There are a lot of shared resources, and large enterprises already trust the LF. If you go to most tech companies, particularly big tech companies, they work with the LF. It's easier to get them to use or contribute to LF code than something they're going to have to send all their lawyers through. So I will point out, and I'll mention this some more in the next slide. At the LF, we support a large array of different kinds of projects, not just open source software. We can do standards. We can do data. We don't really do data in Hyperledger, but this is something that they do in LFAI. But it's really all about openness and collaboration. And so, yeah, in summary, we encourage developers to contribute code and allow communities to build and sustain that infrastructure. And that's it. Thank you very much. Can I answer any questions? Anybody from the web too?
No, not seeing any questions online.
Nitin's got his hand up. David.
Clapping. Thanks, Nick.
Oh, Nitin's like,
Ivan.
Sure. Is the process which a project and the Hyperledger Foundation is based, like from incubation to or hibernate incubation, I think like is the first step. So becoming that something that's promoted to then be used by the community, and what stages basically.
That's a great question. So, we have a project proposal process if you want to contribute code, either as a project or a lab. This is all documented. A lab proposal is very lightweight. A project proposal is a little bit more heavyweight, but not too challenging or difficult. And it's really just about making sure you have the people who are in place who can grow a project. and can really try to build that diverse community. And led by David, who's on the call, we have a great community architecture team who can help you, try to grow the community, build a diverse group of contributors and maintainers, and increase adoption. The mechanics are, they're not very interesting. It's like fill out the proposal, file an issue on the GitHub, but yeah, and you give a presentation to the technical advisory committee. So
Thank you.
yeah. Anybody else? You talk to David. I'm putting David on the hook.
Hey, Hart, I had a question at this meeting, and thanks for the great presentation. And say hi to the guys in the room as well. I think Sophia's somewhere at the back.
Yeah.
One thing I encountered at my previous role in a large financial institution was that there's a new requirement now from 2021. It's from the presidential order to ensure that from a resiliency and cybersecurity perspective, that every library, every piece of code is accounted for. In the event that there is some challenge, then it's addressed. It's tied into the security incident reporting infrastructure. So as you discuss this open source, that it's community-driven project, is there initiative to sort of pipe that through that sense of understanding as to where the code is coming from? Because that will make the consumption of software by your eventual constituents, which is commercial entities and banks, a bit more faster. Because then there's another hurdle that the open source community would have to deal with, is who really certifies the software from listing all the libraries and so on and so forth that goes with it. So I'll pause here to see if that made sense, Hart.
Yes, I believe you're talking about SBOMs or software bill of materials.
Yes, it's sort of, yes.
Yeah, so that is on the agenda for us to roll out for projects. We are working on it. That and CBOMs are cryptographic bill of materials as well. So I absolutely agree with you. These are important, particularly for fast security responses. If there's a component of your software that has a bug, you need to be notified, and SBOMs are a great way to do this. So yeah, this is on the roadmap, and this is definitely something we're working on.
Fantastic. Thank you, Hart.
Yeah, absolutely. Great question, by the way. Always happy to talk about SBOMs. The OpenSSF, which is another sister project to Hyperledger, does a lot of work on this. And we're in the process of rolling out their solutions for these things. Great. Any other questions? Awesome. If not, is it Connor or Matt next? Awesome. Well, thank you, everybody.
Thank you, Hart.
Let me sign out, and I will turn it over to you. Are you on?
I'm on the Zoom. Do I need to come off mute at all, or is it all?
No,
keep it. Right.
You just need to
Just share
your
screen?
What?
It's the buffer. Right. So unlock the doors with the right-hand panel, and then go to the right, and there's a door there. Okay, that's showing all right. Everyone can hear me? David, you can hear me okay?
Yeah, and I can see your slides.
Excellent. Okay, so my name is Matthew Whitehead. I've got a little page on me in a second. I'm talking about, so I work for Kaleido. I'll skip a slide for a second. I work for Kaleido as a principal engineer based in the UK, as you can probably tell from my accent. We have an office down in Southampton on the south coast. And this presentation is really about running Besu in the Enterprise, specifically with an update on what's been going on with Besu for people with an enterprise hat on. What's Besu been working on, what we've been contributing to Besu, focused on enterprise use cases, what's coming next, and what are we thinking about next as the Besu roadmap unfolds. So I'm going to cover that 20-25 minutes. I'm going to try not to overrun. And then, yeah, feel free to ask questions. If you want to ask as we go, feel free if there's something on the slide you want to ask about. So just a bit of kind of background, a bit of history. So Hyperledger Besu, it's been around for about the last kind of 5-6 years ago, started as a project called Pantheon. In around 2019, Kaleido first started offering Besu as a production Ethereum node runtime. Kaleido itself is a Web3 vendor with a whole variety of node running solutions, support solutions, self-hosted and hosted solutions for Web3 technologies, signing capabilities, nodes, Hyperledger Firefly hosting. And I'm sure Sophia can answer questions if people have kind of questions about Kaleido products. But the relationship between Kaleido and Besu is very, very close. So I am a Hyperledger Besu maintainer. So I work with the core Hyperledger Besu team from a pure open source point of view. You know, all the things that Hart was talking about the kind of collaboration across the open source community. And what I bring into that world among various things is Kaleido's experience of running Besu for enterprise customers, for enterprise use cases. So when we have production systems and we're running Besu and we're diagnosing issues and we're standing up nodes and we're setting up QBFT chains and so on, we're able to feed all of that experience that we gain by doing that into Besu just to make it a better product, to make it more enterprise ready, more enterprise focused. And that's where a lot of the features I'm going to talk about have kind of come from. We also lead the Hyperledger Besu roadmap for enterprise features. So in some respects, if you go on the wiki and you look at the roadmaps part of the Besu wiki, there's this kind of public permissioned kind of separation of duties, if you like. So there's a huge amount of core capability in Hyperledger Besu, all of the EVM layer, transaction processing, and so on. But there are things which are very public chain focused. So EIPs, which must be implemented by public nodes in order to participate in the public Ethereum chains. They are very public focused. And likewise, there are lots of things which are enterprise permission chain focused. The QBFT consensus algorithm, for example. So I lead the enterprise roadmap side of that picture. Again, bringing all that experience we have of running Besu in production. What I want to do is just kind of summarize the last kind of 12 or 18 months of Besu development in the enterprise space. I've got a slide with a bit of detail on most of the things here, just to recap. I'm not going to spend ages on each one, but I just want to touch on a bit of detail around what are each of the things we've been working on, going back to kind of mid-late last year. And I'm also going to just talk about some of the things that we're working on as we roll into kind of the second half of 2024. So let's just look through some of the recent features that Besu's introduced and why they're so important for the enterprise. So the first one is support for the Shanghai fork of the EVM specification, specifically support for using the Shanghai fork with QBFT chains. So Shanghai itself has been around as an EVM specification for the public Ethereum chains for about a year or so. But what was kind of lagging a little bit behind the public space was, what if you are a permission chain QBFT user and you also want Shanghai? That capability wasn't there. It wasn't supported. And the reasons you might want to be following closely behind the public chain EIPs is that some of them introduce enhancements to the EVM, the virtual machine, that actually enhance kind of performance, optimize Solidity code. So even though some of the specifications like Shanghai introduce things which are very public chain oriented, the basic EVM spec grows over time, and permission chain users want the benefit of that. They want the optimizations that brings to executing Solidity compiled code in an enterprise Besu chain. also, because the EVM evolves over time, it's not just the nodes and the chains that need upgrading. What happens is all the tooling, all the developer tooling, all the Web3 tooling that developers are using, that moves with the public chain space. Okay, the public chain space moves the tooling at the same rate roughly as the public chain space. What you can't then do in the enterprise world is we're fine, we're going to lag behind that, because all of your Web3 developers, they come onto Discord and they say, hey, I'm using the latest libraries of OpenZeppelin, I'm using the latest version of the Sol C compiler, and I'm trying to run against a QBFT node that's not working. So Besu for Enterprise has to maintain a good rate of development on supporting those public-oriented forks that affect other tangential technologies like developer tooling. So the big one with Shanghai was that OpenZeppelin 5, that defaulted to needing Shanghai enabled on your chain. And we had an increasing amount of discussion on Discord from developers saying we can't develop against the permission chain. And another thing that we talked about across the maintainers was the fact that often we would be regularly configuring chains in a different way to the way that someone running a chain against a public network would. So you'd find that you were having to provide lots and lots of settings which are very permission chain specific in order to get a chain to perform well, to be stable in that kind of environment. So what we did with the community was say, well, actually the defaults aren't really good for everyone. What we should look at is having profiles which set defaults according to a kind of a profile of a pattern of how you're going to use Besu. So what we did was we just started with 2 or 3 of them. Primarily, we have the kind of the public defaults. So if you're running against with a client against public mainnet, you get all the public defaults. So you get a transaction pool that's oriented towards running in the public network. You get tuning options set sensibly for large numbers of accounts, large numbers of signing addresses, which is what you're going to have in a public chain. If you're running Besu yourself, you want the defaults that say, well, transactions I put into my node, I want those to be prioritized and so on. And obviously all the gas settings, all of those need to default to being based on the gas price, the fluctuations, what's going on in the public chain. For enterprise or permission use cases, it's really common, for example, to be running with free gas. So the gas price being set to 0 is super common. We do see occasionally people wanting to run with non-free gas to maybe emulate the public chain. Things like setting gas price to 0 as a default made a lot of sense if you're an enterprise user. There's a totally different transaction pool, which we recommend using, called the sequence transaction pool. So the enterprise defaults set the transaction pool to be the sequence one. The sequence transaction pool itself, I'm not going to cover here. That was some work done last year, and it was an evolution of the previous transaction pool. But we found, talking to enterprises, what they wanted was not because there aren't the kind of the crypto economics of whoever pays the most, whoever gives the highest priority fee gets their transactions in first. Enterprises tended to want, I kind of want it much more FIFO, much more like a queue. I've got applications everywhere. I don't really want to diagnose why this transaction that was submitted an hour ago is still waiting and all these other ones are going through. I really want it much more queue-like, much more like things come in, they get mined into blocks and they go out the other end. So we have this thing now called the sequence transaction pool, and that we find satisfies the kind of the typical permission chain use cases much better, and that's turned on by default if you use the enterprise profile. Similarly, things like the way that pool is tuned. Most enterprises don't want each node to prioritize the transactions that came to it, because you're not running nodes just for you, you're running them to be shared across applications and so on. And of course, all the way that the profiles work is that you get a bunch of initial defaults, which are sensible ones, but you can override all of them. You can then tune and customize exactly as you'd expect, but you don't have to set so many to get a nice performance stable chain. We also looked at what enterprises care about in terms of minimizing the chances of a node through GitOps or some other means being accidentally downgraded, upgraded, and the data underneath Besu being corrupted through that process. So normally that's not going to be an issue. Normally Besu make sure that a downgrade is safe, and most of the time that's fine. But what we found enterprises feeding back is we want slightly more kind of robustness than it will probably be fine. What we want is we want to be able to say, this definitely won't downgrade data unless you explicitly say, I'm happy for that to happen. So version downgrade protection is a way of ensuring absolutely that if you have issues in your GitOps pipeline, if you end up running a node at a version below the one it was, you're not going to corrupt the data, you're not going to end up having to totally resync a new node. This is a super recent one. So this feature merged into main Besu 2 days ago, and it's been something I've been working on for the last few weeks. And this is support for a combination of things, which again have been in the public chain space for the last at least kind of 12 months or more. And the support for enterprise QBFT chains have just been lagging behind a bit. So this is support for QBFT chains using the Bonsai database, which is a database that's better suited to storage savings and better suited to reducing the latency of reads of world state, and combining all of that with SnapSync, which is the recommended way of syncing a new node quickly against an existing chain. So again, the combination of those things with a QBFT enterprise chain wasn't supported, didn't work in the way that it should have done. And there are lots of reasons why enterprise want those features. They want Bonsai because they get storage savings. They want Bonsai because they get better smart contract performance. They want SnapSync because if they add a node to a chain that's 10 million blocks deep, they don't want that node to take 6 hours, a few days to sync with the rest of the chain. They want it to take of the order of some minutes. So what you have now in Besu, not in a release yet, as I say, it merged just a few days ago, is the ability to have an existing chain that's millions of blocks deep, decide you want to add a node to that chain, and that node will use the SnapSync protocol to download the world state from a recent block called a pivot block, which is 50 blocks behind the current head of the chain. And specifically, one of the benefits of SnapSync over other the FastSync protocol is it'll only download the leaf nodes. So it's doing much less network activity, and it's trading that off for CPU activity to recalculate the state tree from the leaf nodes. So this node in this picture, node 5, is going to ask all of the 4 nodes. It'll share out the requests against all of them. For the world state 50 blocks ago, that's a relatively constant time activity. So if this was 10 million blocks in or 100 million blocks in, the world state might have grown a little bit, but if you have accounts or contracts changing state, it's going to be relatively constant time, however long the chain is, to sync this new node. And within the order of some minutes, your node is totally synced with world state, and it can continue then participating in the chain and carrying on from the other blocks that the chain has got up to by that point. So this brings with it all those benefits I mentioned. It's currently an experimental option. So the way that this is enabled is, firstly, you have to go to your existing node and enable another experimental option, which is to make those Besu nodes serve up world state in the correct format over the Snap protocol. So that's the top option. You go and turn off your nodes one by one, restart them with SnapSync server enabled, and then they know to serve up Snap protocol world state. And then for the new node you're adding, we have this new experimental option, which is called SnapSync BFT enabled. We turn on SnapSync mode. That's an existing mode. We turn on data storage format Bonsai, again, an existing setting. We choose how many peers we want as a minimum number of peers to start asking for SnapSync data from. Again, this is the default of 5 is a very public chain oriented number. And again, this is probably something we will add into the enterprise profile defaults. In an enterprise setting, you'll probably find just having one other peer to ask for SnapSync data from, because you don't have the trust implications of a public chain. The trust model is different. If you can connect to a node, if you have network access, MTLS is all set up, all of those things, you're probably not worried about, is the world state that one node is going to tell me legitimate or not? So setting sync min peers to 1 is a recommendation, so that your node doesn't have to connect to everyone before it starts syncing. And then again, within the order of a few minutes, that new node is totally synced and able to contribute to the chain, either as a validator or a JSON RPC node, however you configure it. Okay, another one that's been added in recently is that, and as a vendor who runs production Besu systems, we have times when we're having to diagnose issues with chains. We're looking at maybe a chain has stalled for some reason, and whenever you have to kind of deal with those kind of issues, you hit the pain points in the product, you hit the pain points in software, and you look at how can we make this much easier to resolve in future situations. So the case of a QBFT chain stalling is not uncommon for various reasons. Nodes maybe go down for maintenance, maybe there's a networking issue between nodes. And periodically you find yourself having to look into why aren't there enough validators in a QBFT chain to reach consensus and keep producing new blocks with transactions in. So if you take the example of there's a 4-node chain, if 2 of those nodes go offline, there aren't enough validators to produce blocks. And this kind of snapshot at the bottom here shows how lightweight the logging in Besu was, how kind of, I think Besu is often optimistic that stuff will just happen and work out, and you don't need to really look at the logs too much. It'll just kind of come out in the wash after a few minutes, which is lovely unless it's 3 in the morning and you're trying to diagnose an issue and you really want to see, is this progressing, this chain? Do I need to do more to make this chain unstuck? So this is an example of some logs for a 4-minute outage of a chain where it stopped mining blocks. So we can see we got blocks 29, 30, and 31, nothing. Like 2 of the nodes went down, nothing, no logs. I could turn on debug, I could turn on trace, and I could go and look into much more detailed things about what messages are coming in and out of the node. But really at this point, transactions can't be included in blocks. Blocks aren't being mined. The only thing I care about is this in the process of resolving itself, or do I need to go and do much more work to make that happen? And after starting the 2 nodes, and this is a real example, eventually they're all happy and they reach consensus, and then they start producing new blocks again, which again is kind of great. But you kind of want to know if in that period of time you need to be doing something. So baked into the QBFT consensus algorithm is a concept where a node gives the other nodes a certain period of time to all agree that they're on a given round. And if they don't, they increase the round, and then they increase the timeout for that round. And so they increase the rounds kind of exponentially. And that's the behavior, that's the logic you want to see in your logs, to see, okay, have the other 2 nodes been restarted? Are they talking to me? And are they slowly approaching the round that I'm on, which is how QBFT works? If everyone could go on mute if they're not asking a question, that'd be great. Thank you. So what we have now is just in info logs, not turning on debug, not turning on trace, which might look noisy, but again, as I say, if nodes aren't producing blocks, it's the only thing you really care about seeing in the logs. Is now you see the same situation, but we get just the right amount of information to know that this chain is fixing itself, and we just need to make sure that pans out. So we have a case where blocks are being produced, 17 and 18, that's all fine. 2 nodes go down. We start to see QBFT consensus detail saying that this node has expired the first round, and it's going to give it 16 seconds to move before it moves on to the next one. And this is where it and its other peers have got to so far. So the 2 that are remaining are both on round 2. That's all good. This continues and it goes, right, now I'm moving on to another round. I'll double the timeout. I'm with my other buddy, but we haven't got enough still to produce blocks. That keeps happening. And then, hey, eventually one of the nodes comes online. They're down at round 1 and we've moved on from there, but they're down at round 1. And I can see, okay, so firstly, I know there's a connected node. So that's great. That node's been restored, or the network's come back. And hey, then the other node comes back. So the other 2 that had an outage, they're on round 1. And then over a period of time, there's kind of some missing logs in the middle. Over a period of time, all the nodes all reach agreement that they're all on round 6, it will have taken a few minutes. I've chopped off the timestamps to fit this on, but this will have taken a few minutes. But during that time, as an operator, as administrator, I can be watching this, knowing this looks like it's all coming, everything's connected, and this is just going through QBFT logic, and everything's going to be fine. And hey, at the bottom, then we see new blocks. So again, this comes out of sheer kind of on the coalface experience of diagnosing chains that have stalled, that aren't producing blocks, and so on. Again, this enhancement went into Besu main a few days ago. And then lastly, I just wanted to touch on performance, because performance comes up a lot when we talk to enterprises, and it's an area that we in Kaleido decided we were going to invest some time to look at what's the state of play for enterprise QBFT chains in terms of performance. And if you go back, this is totally independent analysis of Besu from a couple of years ago. And if you go and read this paper and look at the results most people kind of were talking about over the last couple of years, generally the consensus was you could hit kind of 400 TPS, 400 transactions per second in a 4-node chain. So all the chat between the QBFT nodes, that takes there's the cost there. There's latency between those nodes is important. But roughly speaking, you can hit kind of 400 TPS without trying too hard. And then it's quite hard to go beyond. And obviously, when you're talking to financial institutions who have, traditional messaging systems, many orders of magnitude, higher than that, the discussion about what's the performance we can get out of a chain that's running QBFT protocol, what can we expect? How do we need to plan for scaling, and so on? So we thought we should spend some time looking at, well, is that where Besu is today? And we did some collaboration with one of the other Besu maintainers, spent a lot of time doing things like profiling the JVM, looking for bottlenecks, looking for hotspots, understanding where those were. I've put a little shout out there because there definitely wasn't time today to go in detail on all of that work we did around, what are the performance issues in Besu today. So in a few weeks, I'm doing a Kaleido hosted webinar on more of a deep dive of Besu performance. But we spend a lot of time running tests, profiling, analyzing data, and looking for the hotspots. And that led us to understanding, okay, how do we tune Besu to reduce those hotspots? And then the ballpark numbers we kind of now see reliably with a 4-node QBFT chain. I've just put these as kind of ballpark numbers that are fairly easy to recreate. Using 4 nodes, I've put numbers up when I run it, when I run QBFT performance tests locally on a laptop, when I run them in an AWS EKS cluster. And just by looking into those kind of bottlenecks and understanding how should we tune it to behave in a more performant way, we're now seeing kind of much more 500, 600, 700 TPS numbers as very achievable. These are super achievable. They're not, absolutely huge EC2 instances to get these numbers. These are very achievable numbers. And the webinar that I'm doing in a couple of weeks, we'll talk about how to configure Besu for that. The bonsai work that I mentioned a few slides ago kind of contributes to part of that. So the numbers on the left are with the traditional forest database, which again doesn't have the performance benefits of state reads from world state. So if you're doing like an ERC20 token transfer between 2 accounts, some of that is reading because you're reading the current balance of the accounts. Some of it is writing to world state. Bonsai really improves that reading performance. And we think that this was a super sniff test of the Bonsai DB work before we'd even delivered the experimental support for Bonsai DB. So we think there's more performance to come from the Bonsai DB support. But it just shows, another 10, 15% bump just by turning on Bonsai DB. And so the work on Bonsai has kind of had that side effect of improving performance as well. And another thing I'll touch on in that webinar is these are individually our ERC20 transactions, which is a kind of everyone understands what an ERC20 is, so it's a good kind of ballpark measurement to do these numbers off. What we do find is, again, financial institutions, for example, who are looking at what overall throughput they can achieve on an Ethereum blockchain, they tend to look at batching transactions into single Ethereum transactions. So maybe redesigning their ERC20 so that it takes 10 token transfers in a single Ethereum transaction, does them all in one transaction, and kind of does a batching model. And we see that if you see that, you see orders of magnitude, many orders of magnitude improvements on these numbers. And again, I'll kind of talk through that, but it does require careful crafting of your smart contracts and understanding the trade-offs of batching your transactions versus having them individually processed. But I just wanted to say that that's definitely a focus area that Besu as a community and Kaleido as a company knows is important to enterprises, has spent time looking at and improving, and I think is going to continue to be a focus area for the foreseeable future. Okay, so I think that kind of covers everything. It doesn't cover everything. Yeah, slide for this. I'm just going to go back just to the roadmap on a bigger screen, just to say one thing about what's coming next. And that's really that top box on the top right, really, and a little bit of this one here. So what are the things that are still being worked on that are actively kind of being discussed by the community? So there's one here, which is kind of work in progress, which is empty block periods. So if you're an enterprise permission chain and you have some time for the day where there's no transaction traffic, do you want a block still mined every 2 seconds, which is taking up storage? Probably not. Empty block periods where you say, well, it's 2-second block periods when there's transaction traffic, but it's 60 seconds if nothing's going on, just to kind of keep the drumbeat to make sure that the nodes are still chatting and mining blocks. But let's make it 60 seconds or 2 minutes or 5 minutes when nothing's going on. So that's something that's being looked at by some other maintainers. The next area of work for Bonsai specifically, which Kaleido was actively contributing to, is that Bonsai gives you this ability to save a lot of storage space by automatically pruning world state for blocks past about, I think it's 512 blocks back by default. So if you're asking about the state of a smart contract 10,000 blocks ago, Bonsai DB is not well suited to that because it's designed to give you recent state for recent blocks, but not necessarily be able to inquire about arbitrary state at an arbitrary block in history. Obviously, that gives you a lot of benefits around storage, but again, if you talk to an enterprise who expects to be able to quickly and easily interrogate world state from their blockchain at any point in time, they need some options around how do we rebuild the state to block 50 if we're 1 million blocks into a chain? How do we make sure we can easily access archive data about world state if we've moved on to Bonsai, and Bonsai is inherently not designed for that? So Bonsai DB archive capabilities is something that Besu is looking at, Kaleido is looking at, and some other work around QBFT performance. All those logs I showed you are great, but actually there were still minutes of downtime when nodes were recovering and going through the QBFT algorithm. We think there are some things we could look at there to let an administrator at least say, look, just all of you jump to a new kind of round in this block, and then you should be able to go much more quickly. And I've talked about more performance enhancements. I think we'll see more work there. So I can really go back here. I guess just to reiterate, Kaleido is kind of leading the enterprise roadmap for Besu. It's a totally open source project. Come to Discord, find the GitHub repo, raise issues, add comments to issues, come talk to us. Totally open project. We'd love to have conversations with you about pain points you have, anything like that. Any questions? I think that's me done.
That's a working group.
The financial working group. Yeah, so there's a financial services, financial special interest working group. Is that the right term? Being hosted by someone from DTCC, I believe. They meet every 3 weeks on an online call on a Friday. That's looking at what does Besu need to do in order to be a really, really good EVM product for financial services groups. Lots of discussion on privacy. So privacy is the topic that everyone's talking about. And there may well be a spin-off kind of subgroup of that working group just to talk specifically about privacy. Also performance has come up. So I'd recommend you reach out to myself or Sophia or Hart if you want to get the details of joining the financial services working group. Any questions on the phone? Any on the chat, David?
No. If anybody does have questions online, feel free to put it in Zoom chat or come off mute.
Just gonna add, you don't need to be a Hyperledger member to join the working group. There's recordings of the calls if people want to hear what people are bringing forward as requirements.
Yeah, absolutely. Yeah.
To participate.
Okay, thank you very much.
Thanks a lot. So while Connor sets up, I'll ask you, so you say there's a lot of finance.
Yeah.
It's like, there's a lot more, I guess I counterintuitively thought, or I thought that there would be a lot of enterprise demand for that, but are we seeing a lot of dynamic node behavior in enterprise networks?
I think it possibly stems from the sheer amount of time that any other type of thing takes.
Which is, yeah.
If you have a chain that's got a long history.
Mhm.
And so I think enterprises probably appreciate that. Well, firstly, you have enterprises already with very long chains where I go to add a node and this is literally taking me hours and hours and hours. And those chains are only going to get longer and longer and longer. So I think it stems from knowing that it's the direction of travel. I think from Besu's point of view as well, there is that balance of it serves, two needs really well. It serves the public chain, it serves the enterprise world really well, but it can't maintain every single feature forever. It can't have a code base that grows and grows and grows and grows. So there's also, I think, a degree of the enterprise space in Besu's land needs to keep up the public space because public chains are going in one direction, and Besu can't maintain and keep up to date every feature. So I think because Snap is the way to do public chains,
It's definitely the way for public chains.
I think there's a degree of pragmatism as well around how does Besu continue to be, a workable code base that isn't totally unwieldy.
Yeah,
I think there are things like, yes, it's useful for enterprises, and at some point other features are going to drop from Besu.
sure. No, that makes sense.
So is microphone picking this up and everything else?
Yeah, your audio
Cool.
sounds good and I see your slides.
Awesome. All right. So I'm going to be talking about Hyperledger Web3J during the talk today. I know in terms of the meetup, it said Ethereum developer tooling, and I guess in the context of Hyperledger, certainly Hyperledger Web3J is one such piece of tooling. There are other pieces out there, but Hyperledger Web3J is a new project that came to Hyperledger at the beginning of the year, and something that I've invested a lot of time in over the years. So let me give you a rundown of it. For those of you who have not heard of it, I'll be just providing a bit of background. And for those of you who are familiar with it, you'll just get a bit of an update on what we've been doing with it this year and what's going to be happening as well. So to give you a bit of background about myself, I started off in the financial space, working on various sort of institutional financial applications, and moved full-time into the world of blockchain back in 2016. I came across Ethereum, and one of the things that I saw was missing was the ability for developers who were working on the JVM to actually work directly with Ethereum technology. Even back then, there was a lot of talk about the premise of this technology. You had companies like Digital Asset, for instance, doing what ended up being a failed initiative with ASX, but lots of other people even back then really saw the the potential of the technology. And so I wrote Web3J off the back of that. And I guess in the years since then, I've continued just to really contribute as best I can to the overall, Web3 space. I spent a number of years chairing the Enterprise Ethereum Alliance Client Specification Working Group, which was responsible for creating, I guess, the first enterprise Ethereum specification. I wrote a book as well a few years ago, just Blockchain Innovators Handbook. I did have a podcast, but I've put that on pause for the time being, just other initiatives we're working on. But yeah, that's my background here. Web3 Labs, though, we're really a decentralized infrastructure solutions provider. We have really three core offerings. One of them is ChainLens, our blockchain explorer technology. We also have Web3J, which we continue to maintain and support. And also we work on Hyperledger Besu as well. We've worked with a number of different customers over the years, some of them big enterprises, big tech, but also a number of different organizations from the blockchain space as well. So in terms of breaking down really the core, I guess, tenets of what we do. So at the top, we have ChainLens, which is very much so focused on your blockchain type data and analytics. And this is something that we've been working on for a number of years, and is, I guess, a well-established product for us. We run approximately 40 customer instances of it, and that's SaaS provisioned. We also, with Hyperledger Web3J, that provides systems integration for connecting, I guess, traditional Java applications with Ethereum compatible blockchains. And then as well with Hyperledger Besu, we provide, we do network provisioning, but also provide production support for it as well. And some of the team contribute directly to it. I'm going to talk just briefly about ChainLens, just to make you aware of it. It's a fast, high-performant blockchain explorer. It's basically, I'm sure many people here are familiar with it, but if you want an explorer that's very, I guess, lightweight in terms of it provides the information you need quickly, and in a way that's user-friendly as well. So we're not bombarding people with all of the low-level information about the blockchain. It's more focusing on the actual assets that are on-chain. This is something that we're very actively investing in and working with a number of organizations on. But it's got all of, you can think of it really as a white label blockchain explorer. We run it for public networks, but then also we do custom deployments as well for companies and brands there. In terms of just breaking down some of the features, we support all of the major Ethereum standards in terms of main tokens, ERC20 fungible tokens, the ERC71 non-fungible tokens, and the 1155 standard, which are also used. People who are working with NFTs now, granted, people mainly think of them in terms of being these sort of JPEGs and so on, but we're working with a number of companies who are really trying to work with the technology, not so much in a speculative way, but to provide it with real utility. And so that includes like gaming studios and also some of the companies in the entertainment industry who are really thinking about real world use cases here. That being said, I think that the applicability of this technology goes so much beyond just the classic sort of idea of an NFT. I mean, really what an NFT is a representation of an item in a digital format, and that item can be absolutely anything. So we're really doubling down on having really quality experience there within ChainLens for that. But then we provide all of the other pieces too, like blockchain analytics. We also decode a lot of the cryptic blockchain data as well. So when people look at smart contracts, you can actually see, what's actually happening there. And there's a number of different features that we've developed just over the years to really help with that. On the Hyperledger Besu side, so like I mentioned earlier, we provide production support for it. And this is, for us, we more work with organizations who have a live Besu network. We don't have like a provisioning platform or these sorts of things. We can assist with the provisioning, but it's our core kind of expertise here is when there are problems with it, being able to work with them to actually resolve those issues. and provide like a number of different value adds on top of that. Then I'm going to talk now for the rest of the time anyway about Web3J. And just for those of you who aren't familiar with it, it's an integration library for Ethereum. So what does this mean? If you think about a blockchain network is made up of a number of different nodes, which is software that's run on a number of computers spread around the world. The thing with these blockchain nodes is that they're optimized for really running the blockchain. And so what does that mean? That means having consensus among participants of the network. It means executing transactions, executing smart contracts. It doesn't mean providing stuff in a really nice user-friendly way. And so hence, if you're a developer and you actually want to work with a blockchain, it's a lot of work to do it from scratch. Web3J started off as an effort to really provide an API for working just with what's called the RPC layer of Ethereum. So you can see here that Ethereum has this JSON RPC layer, which is the protocol that's used for talking to nodes on the Ethereum network. Outside of the world of blockchain, I guess JSON RPC isn't really too well known because it wasn't really well established like these RESTful APIs and so on, and that have become very well, I guess, ingrained, especially in enterprise via the open API standards and so on. It was something that Bitcoin nodes used, and therefore the Ethereum kind of team decided to adopt the same thing. But what it does is it means that developers don't need to implement that sort of protocol layer communication themselves. It's already there. It works for them. But it's a lot more than that, because once you get started doing this sort of stuff, you suddenly realize there's a lot more to it than just a facade over a sort of transport layer protocol for talking to things. And this is where Web3J became a lot more. So for those of you who are familiar with, I guess, what's in the JavaScript space, the best way to describe Web3J is it provides what Web3JS plus something like Ethers or plus Hard Hat provides, where it's got the sort of the low-level kind of primitives implemented, but then it's also got the all of the, I guess, the abstractions for doing things like working with smart contracts, wallets, testing, and so on and so forth, which I'm going to unpack a little bit more. So it was first released back in 2016. So the library's been around for almost 8 years now. It's coming up to 5,000 GitHub stars. It's downloaded a lot. We've done over 100 releases of it. There's I think almost 200 unique contributors, over 1,000 resolved issues. All these sorts of metrics just kind of give you, I guess, a perspective of it. Something that's been very actively maintained, for a number of years. But at the beginning of this year, we made the decision to donate it to the Hyperledger Foundation. And I think the motivations for doing this are quite important to highlight, because we'd spent really the previous 7 years working on this library, supporting it, and we'd been fortunate to have funding to help assist with that. However, ultimately it was always the Web3 Labs team working with it, and we feel that the long-term goal of Web3J, and I think a lot of open source, is that it can continue to sustain itself. And so in order to do that, the good ways to get about it are either you have like a very clear commercial model supporting it, or you have a project which becomes much more of a kind of key sort of public good there. And with Web3J, because it's kind of a plumbing layer, I kind of think of it in the more traditional technology way space as being more like a database driver, in that it's an absolutely essential piece of plumbing, but generally people don't want to actually pay to use it as such. And so, in our minds, certainly Hyperledger is a really good place for it to go to, because of the visibility that comes with it, but also the governance structure as well, so that there's clear sort of processes and so on in place to encourage greater collaboration and contribution to it. And so it's something that we've been having conversations about for some time, but at the beginning of this year, we decided to pull the trigger. So Yeah, I think it's important to highlight, why Web3J is a good idea to use it as well. I mean, look, it's not going to work in every single possible use case. If you're developing a DApp, for instance, then you're going to be better off using a front end, friendly programming language for it. But if you're trying to do something more kind of on the server side, then it's a very solid choice there. The library's been around for a long time. It's been in the public. It's gone through, feel it's very, I guess, battle hardened, so to speak, just from being out there for so many years. One of the other key things as well is that with the JVM, it's a statically typed language, and so that means that you get type safety enforced at the actual language level. But what Web3J does, it provides type safety going from the Ethereum virtual machine to the JVM. So developers don't need to think about mapping like a native Ethereum type to a native Java type. Web3J takes care of that. We've already mentioned about the fact that it provides the JSON RPC support. It provides the functionality for generating wallets, for signing transactions, integrating with hardware security modules. It also provides a lot around the testing side as well, and the build tooling too. And really what this means is that it makes it a lot simpler for developers to get productive without actually having to install dependencies and so on. So, for instance, for a Java developer, all they need to do is they can either install a CLI, or they can just add a build dependency to their project, which I'll cover in a minute. And what that gives you is you get the Solidity compiler as well as EVMs for actually testing against, all from within the Java environment. They don't need to go and download and install Solidity. They don't need to go and find like an Ethereum node to run. All these sorts of things just add to the cognitive load for people when they're trying to get started with it. And so this is, I think, key things in terms of how it's evolved over the years. It's also very modular as well, in that if you just have specific features you want to pull from it, you easily can do that. And it works very well with Besu too. I think this is another key point here. Besu uses Web3J, Web3J uses Besu. There's a nice reciprocity. Yes, you know what I mean. It's between the two projects there, and so that's another side too. Especially when you've got these enterprises that have got a lot of JVM developers there as well. It's nice to kind of have that. So I've kind of gone through, I guess, a lot of these key features. The other thing to talk about is that it enables you to work with smart contracts natively from within the JVM. So you've got a Solidity smart contract, and you can do everything from within the JVM to work with that smart contract once it's been written. You don't need to then do anything natively in Solidity once it's there. We have a nice integration with ENS as well. It's Android compatible. We keep it up to date with the updates that are happening within the Ethereum, I guess, world. Most recently, it was the first developer library to implement blob support as well when that came out, and it's also got command line tools with it too. In terms of networks, it supports. If it's an EVM network, it can work with it. I'm sure everyone here is familiar enough with some of the different flavors. Here are some of them. And then in terms of getting started, the team have done some sessions already within Hyperledger as well. There was a workshop a month or two back, and so there are some YouTube videos available where you can go back and see the specifics of what was covered. But really, there's two ways to get started with Web3J. One of them is via a CLI, which just sets everything up for you locally. And the other is if you're a developer, then you can just add a specific dependency in, and everything gets going from there. I mean, what this looks like is that if you're on Windows or Linux, you just have a single line to do this to install the project, and then you just type Web3J new, and that'll scaffold you a project. You can think of it as like scaffolding a Hello World type project for you. But it also comes with this, I guess, ready-made ERC20 and 721 projects too. The other side is you can have specific, you can add it in as a dependency as well to your build tools. And once you've done all of that, though, and this is where it is really neat, the stuff that happens behind the scenes, in that as part of the build process, if you've got Solidity code there, it will compile it for you. It will actually look at in the headers of the Solidity file to see what versions of Solidity it needs to use, and then it will go and download those versions of the Solidity compiler for you. So it will download the most recent version of the Solidity compiler that's compatible with what is specified in the source code, which is a neat feature, because it means people don't need to go around installing Solidity on their laptops and these sorts of things. And it generates the binary and API files for deployment too. So I suppose in a technical perspective, what it means is when you've got a Solidity file like here, and this is a standard ERC20 token, you just have some nice Java code there that enables you to query methods on it, and also perform transactions there as well, and deploy the contract too. So Web3J takes care of all of that plumbing. The other thing, and this is where some of the stuff that's got some really neat features to it as well, is we have annotations for testing, for your test environment. So if you think about developers, when they, especially if you're in an enterprise and you've got a specific version of Besu that you're running against, or you have a Dockerized environment that you want to simulate the same configuration as what you have in production. With Web3J, you can just attach annotations to your test there that can do whatever you have in your unit test, be it doing stuff with Solidity contracts or doing other, replicating other logic of your system. And you can say, this is the EVM node type that we actually want to work with. And, again, to point to the whole thing of Besu, we have the Besu EVM comes with Web3J. So what that enables you to do is test everything really rapidly without having to actually leave the JVM environment of your IDE. And so, if you're thinking in terms of the best way to actually test Besu, is Web3J is the best way to do it, because you can do everything within the JVM there. You don't have to jump from node across and so on there. But that being said, Web3J also supports dependencies as well of Solidity smart contracts too. So if you say, you've got some smart contracts and you want to pull in OpenZeppelin's latest reference ERC20 implementations, you can just specify what the node package is for those releases of these smart contracts from the OpenZeppelin team. Web3J will pull all of that in for you automatically. So there's a lot on the testing side. And then, when it comes to deploying contracts, it's all fairly straightforward, just a few lines of code. You basically need a wallet, you need to load some credentials from somewhere, you need to connect to a node, which is the next line, and then you just need to deploy a contract with a greeting. So it's always the target is what's the minimum amount of code for someone to actually interact with Ethereum, because the learning curve is crazy steep anyway when people first get into blockchain, and we kind of think that we've distilled it down as much as we possibly can for people. The other thing as well is that we can do, there's some neat one-liners you can do in there too for just processing events on the blockchain. So if you want to just listen to all transactions as they're coming in, you can just type something like this, and then you've got something that's just processing all data as it's coming in. Or maybe you want to subscribe to all transfer events associated with an ERC20 token. Again, it's just a single one-liner in order to do it. And that's the sort of technology that enables you to build these sorts of things like explorers, where you have these listeners that are just listening for transactions coming in and then persisting it somewhere. Of course, Chainlens is built on Web3J, which is where we want to plug. You can interact with smart contracts, as I kind of mentioned just now. And again, this kind of, if you've used a block explorer and you have these screens there for being able to read information from smart contracts or write to them, again, you can do all of that stuff in Web3J as well. This is an idea of what it looks like in a way that's, I suppose, less programmer centric. Yeah, and so I've already covered that. The other thing just to talk about, these are some of the things we've done, I guess, in the first 6 months of this year with Web3J. So one of the features is being able to provide quite granular information about the smart contract environment with which you're actually you want to run tests or compile against. So what you can do is you can have like one Solidity source set here, and you can say, okay, I want this Solidity source set to be compiled against the Istanbul release of the EVM. I also wanted to use this specific version of the Solidity compiler with these optimizations. So it's quite powerful because it just gives a lot of flexibility. You don't have to have just one version of the EVM or one version of the Solidity compiler being used for the entire project. Then, like I mentioned earlier, the blob transaction support, that was a big one to actually get done. We've also done like a few more kind of what I call, I guess, sort of BAU type updates, to use that word that enterprises love, but it's moving to Gradle 8.7, it came with a number of performance improvements and so on, and also going to JUnit 5. But another one is to talk about one of the Bouncy Castle updates. Now, for those of you who've not heard of Bouncy Castle, it's actually a very well-known cryptographic library used throughout the JVM ecosystem. It's got a lot of things like the elliptic curves that are used by Ethereum. Now, there's like a critical vulnerability that was found in a specific version, and this was affecting the users of Wallet Connect. Like Wallet Connect is a user of Web3J, and so then you think about a number of people using Android phones with Wallet Connect, they're directly affected by this. So we had to get a release out for that. So again, it goes back to this whole thing of the importance of this sort of open source, but also the importance of being able to maintain it as well, because it ends up in all sorts of places. And you don't want a repeat of the OpenSSL vulnerability from a few years back, where there's like a single maintainer responsible for this library that was being used by a lot of people and organizations. The stuff happening currently with Web3J, so we want to enhance the Web3J Solidity debugger that we've got, also bringing in support for the account abstraction via ERC 4337. What we've found there is that right now in Ethereum, there's no kind of unified approach for supporting account abstraction. You've got a number of different vendors who are kind of proposing their own approach. It's not like some of the IPs where it's like there's a very clear method that's going to be followed by the community. So that creates a little bit of a gray area around it. There's some stuff around generic structs. So this basically is just more having flexibility with being able to work with work with smart contracts without necessarily having all of the source code to hand. And then finally get out the Web3J 5 release. Then finally, if you want to get involved, Discord's a good place to speak with the team about it. There's a GitHub link there, but if you search for Web3J, you'll find it pretty easily. But again, any contributions always, welcome. I think something that sometimes people don't realize about open source is that it doesn't have to be like a big fancy pull request or, doing a whole load of coding. It can be as simple as just fixing a bit of documentation. Any contributions always helpful there. So, these are some of the links there. The other thing I would mention is that we've started putting out more and more content just to support the developer community on the Web3 Labs blog. So yes, there's updates about Web3J, but then also talking about things like gas cost optimization, upgrading smart contracts, what vertical trees are, for instance, and these sorts of things too. So there's more and more useful content that we're putting out there. And then finally, that's all I was going to say. Are there any questions?
Check the chat.
Yeah, I had a question on this. This is regarding the wallet and key abstraction. I think it's a key feature, but why confined to one sort of Ethereum? And the reason why I ask this is because the software development life cycles for Web3 especially is kind of complicated. It's not singular in any enterprise. For example, we have to look into multiple chains, multiple infrastructures, So I'm just wondering, is that a technical limitation, resource limitation? I would imagine that if you would build this as an omni-channel feature, then it'll help the existing enterprise, which is heavily invested in Java, to use the same technology you have for Ethereum only to expand that to other chains, if that makes sense. So I'll pause.
I think the best way to think of it is that with Web3J, it was very much so, built from a bottom-up approach, right? We came at it from the perspective of, this is what this class of developer needs in order to work with Ethereum. Now, we have in the past done some integrations with some other platforms. I mean, years back there was the Aeon platform, which was what one such one. We did have specific integrations for derivatives of Ethereum as well. But again, the challenge always it's about funding and maintaining it. And I think that whilst you can always there's the potential to get things like grants and so on from other communities to provide sort of tighter integration there. But the thing that a lot of grants overlook is the fact that they're not thinking in terms of sustaining a project for like a 10-year time horizon, for instance. And this is where there is a real challenge there, because this is pure sort of public goods type infrastructure that isn't coming, that you just put out there for the benefit of the community. And
Got it.
it's that's really the challenge. It's not there'd always be an appetite to do that, but again, it's just being able to have a revenue model that works, or sorry, a way to sustain it. That's the key challenge.
Got it. Okay, so one last follow-up from my perspective: the wallet abstraction, does it work with the account abstraction, which is again the idea was to simplify the wallet access? This is EIP 4337. Or does that include awareness from that perspective?
Not at this point, and that's in part because there's a number of there's I think 2 or 3 different companies that are all kind of pushing different, well, not completely different approaches for account abstractions, but certainly pushing it in a certain direction. And so we're not at a point where there is something resembling a standardized approach that's being widely used there. And so there isn't something that makes sense from a tightly coupled to Web3J in that respect. The way that we want to approach it is provide an initial implementation that supports one of the approaches and then kind of go from there. But when we talk about a wallet within Web3J, really what we're talking about is an EOA, or externally owned account type wallet, which is really just used for cryptographic signing. But it could, it can work with like an HSM or something that's available over an API as well.
Got it. Thank you so much.
And we have one other question online. I don't know if Reagan, you want to come off mute?
Yeah, I just want to understand how does the Web3J smart contract wrapper work around upgradable smart contracts? Do you need to how does it can we use the same smart contract address basically with a smart contract that gets upgraded using the same wrapper technology?
The best way to think about it is that you have a one-to-one correspondence with a smart contract and a Java wrapper around it. So if you have like an upgradable contract with a proxy, you'll still need to have a wrapper contract for the proxy as well as the actual smart contract that it's a proxy for there. It doesn't come with any proxy type infrastructure out of the box to do that automatically for people.
Okay, thank you.
Anything else? Thank you, everyone. Thanks.
Are you able to allow me to share my screen? I think
Yeah, you should be able to. It's sharing. infinite Zoom loop. It's fun. So, thanks so much for coming, and thanks for joining on the phone, especially if it's a holiday where you are. I really wanted to cover kind of a couple of things, and one of them is how we're running nodes at scale, essentially, and how we're deploying very quickly environments and managing those environments. It's a huge topic, so this isn't going to be an hour on DevOps this evening. I need probably 15 minutes. And secondly, just because I know there's a lot of kind of Ethereum enthusiasts on the call and in the room, we're about to launch impact staking as a solution, and it's our way to change the world of philanthropy. So I just wanted to give you a kind of sneak preview of that before it launches later on this year. Some of you have been asking, who are eSynergy, who are Launchnodes? Essentially, Launchnodes started 4 years ago when we thought that Ethereum was going to be a transformative technology, and blockchain was absolutely going to be a transformative technology. So just before Ethereum became proof of stake, we set up to be the plumbers of the Ethereum ecosystem. We've been working with Hyperledger Besu, we've joined the foundation, Hyperledger Foundation, and essentially eSynergy has been around for 20 years, providing technology consulting to all sorts of kind of government clients, financial institutions, insurance companies, and we, as a kind of Web3 blockchain entity, kind of partnered up, and we're helping deliver payment systems or any kind of blockchain type environments. And I'll whiz through this stuff because I'm just conscious of time and ready to respect the meeting time. So we now have dozens of environments around the world, and our main focus really is putting infrastructure into bare metal data centers, partly as part of our kind of pledge to the Ethereum Foundation and others that we will help decentralize the environment that on kind of Ethereum mainnet. But we also have increasingly customers who are using Hyperledger Besu or other Hyperledger products. And we've now got over 5,000 nodes in the wild, and probably a lot more, because our model isn't to help, isn't to kind of run nodes on behalf of our clients. It's to enable them to run their own nodes. So we provide tools, support, kind of subscription services which allow people to be masters of their own destiny, basically. And our philosophy isn't to move fast and break things, basically, particularly with mission critical applications. And so we love experimentation, we love setting things up in development environments, we love playing with different architectures, but actually, and we've learned some good lessons, having environments that are super robust, self-healing, secure, is absolutely paramount in the work that we do. And most organizations we work with, and this again is why it's really interesting, because coming from a kind of TradFi environment, which is where I kind of cut my teeth, into a kind of world of Web3, there's a very different kind of culture and a very different way of doing things. But in essence, what we're seeing now is people essentially moving from running this stuff locally, setting up test beds, setting up infrastructure in their own environment, then containerizing it, and then moving to kind of blockchain as a service or nodes as a service type models where they can scale up and scale down very, very quickly. And there's really kind of three key areas that we've focused on, and I've stripped out some of the material here, but in essence, that orchestration piece and that automation piece is where we put a lot of attention. And one of the beauties of Hyperledger is you can actually go and download Docker images right off the bat and stand them up very quickly. The second piece really is around infrastructure as a code and using tools like Ansible, Terraform to manage version control, configuration management, and provision new infrastructure. And then the third piece, and you've heard some of it from Conor and actually from Matt, is around automated testing and using tools to make sure that the environments you've set up are doing the right thing, are at the right version, smart contracts are secure, all of those good things.
And that's, so we've invested quite heavily in each of these three areas, and that's where we can spin up services fairly quickly. Stole this from Kaleido's website, thankfully. But in essence, what we're seeing increasingly is organizations going to services like Kaleido and Infura for RPC nodes and other things, and essentially spinning up nodes at scale in a very straightforward way, rather than going through a slow, steady process to do that. And Launchnodes has a similar approach where we make nodes available almost as Lego bricks in public cloud. So we're in AWS, we're in Google, we're in Azure, Tencent, and you can basically go along and buy a Hyperledger Besu node effectively, or a LangChain node. You can have pre-synced nodes as well, so you're not waiting for that kind of catch up of syncing, and every flavor of kind of Ethereum node there as well. And again, our belief is that people will want to run their own nodes in their own infrastructure largely. So they're running these services in their own cloud plane, effectively. They're not our nodes. We're not taking Ethereum from them. They're running on Holski when they want to, and running on mainnet in other instances. And it's actually super straightforward. We hire a lot of grads and we kind of train them up, and actually getting familiar with Hyperledger and Besu is increasingly straightforward for to do. There's incredible amounts of resources out there, events like this, online events. And so it's very easy to experiment and learn. And it's very easy now to scale up and down and to optimize your environments as well. So moving on quickly to the impact staking preview. When we started Launchnodes back in 2020, we decided that we wanted to take staking rewards and point them at good causes around the world. So we've donated tablets to Save the Children. We did a project with UNICEF where we're using staking rewards to fund broadband for schools in Africa. And again, we've had great support from the Ethereum Foundation in doing that, and from other entities. And we've kind of turned philanthropy on its head. So rather than having to donate a large amount to a particular charity, you can take that same amount, stake it, and use the rewards to fund good causes over a long period of time. And if the causes aren't generating the impact you'd like them to, you can take those rewards and point them somewhere else. And we've been doing this at scale now for different entities. And we're working now, we're now plugged into the Lido protocol. So Lido's got something like $50 billion in assets under management. If you go along to Lido in a couple of months' time and want to stake your Ethereum with them, you can now donate some of those rewards to charity, courtesy of the kind of work that we've been doing recently. And that, in a very whistle-stop tour, is Launchnodes, eSynergy, nodes at scale, and impact staking. Any questions? Yeah, David, is there anything on the chat that's concrete?
I don't see anything right now, but if anybody has questions, please feel free to come off mute.
Question just about where did the idea of impact staking come from?
So we basically believe that philanthropy is broken right now. Like, one of the charities we work with is Give Directly, and they started because to put a toilet into a school in Africa was costing $40,000 because $38,000 was going astray to all sorts of other places. And so what we wanted to do was use this new way of generating income, as in Ethereum, and make it straightforward on the blockchain to start moving a proportion of those rewards to good causes. So we did it first with UNICEF Giga, whose intention is to kind of put broadband into every school on the planet. And now we've got Give Directly signed up, we have the World Food Programme signed up, and we're working with other parties as well. So yeah, hopefully that will grow. Okay, thanks so much, everyone. Appreciate that. And thank you for hosting. You're very welcome.
Yeah, thanks everyone for presenting and for joining. And yeah, and the recording will now be on our YouTube channel, so people will view it there as well. So thanks everyone.
Thanks, everyone. Cheers.